In the last segment, we saw the basic concepts of almost all programming paradigms: identifiers, variables in memory, and the environment that links them together. Now let's take a closer look at variables, and we'll see there's a fundamental link between how variables behave and the functional programming paradigm. So let me declare an identifier, x, corresponding to a variable, and bind it to 42. X equals 42. I bind it using a feed paragraph command, and then I browse the value, and I see the value 42 appearing here. Now, let's say the value 42 is wrong, and I want to bind x to another value, 43. Okay, so I have x equal 43. I bind it here, feed region, and it doesn't work. I get an error. Equality constraint failed. In fact, the system tried to make 42 equal to 43, but since they're not equal, that didn't work. And if I display now again the value of x, it's still 42. It hasn't changed. So in fact, in functional programming, it's not possible to change the value of a variable. Once the variable is bound, that's it. A variable can only be bound to one value. Why is it? Well, it's actually a fundamental property of functional programming. Functions, like mathematical functions, x squared, are not allowed to change. And since variables are part of functions, variables can be bound to functions or can be inside of functions, variables share the same property. Once bound, they cannot be changed. This does seem like a big restriction. Well, it is a big restriction. So if it's such a big restriction, why do we make this restriction? Well, this is actually going to the heart of functional programming. Why functional programming is such a useful paradigm? Well, the thing is, in declarative programs and functional programs, you have the rule or the principle that a program that works today works tomorrow. So in other words, a function will not change. So the fact that programs do not change means that once they work, they keep working. They cannot be broken. It's like obeying the law. When you drive a car, you obey traffic rules. And the advantage of this restriction is that you greatly reduce accidents. Okay? And there's other advantages like the signposts following the signs that you get to your destination faster. So you have a higher chance of being correct and less chance of breaking things. Well, exactly the same kinds of advantages hold for the single assignment variables. So, fine. So this seems to be, in fact, reasonable to make this restriction, that there are some advantages from it, which we'll see later. But the question is still, how can you program? Once you have this restriction, you cannot change the value in a variable. How on earth can you program? Well, that's something that we're going to see in a later section.